Welcome to the second part of chemical formulae and equations. So in the first video, we looked at chemical formulas. In this video, we're going to look at state symbols, chemical equations, and I remember in the first video I promised that we'll even look at ionic equations, but because of the skill that you need to acquire on chemical equations, so ionic equations is going to be a short video that we're going to do after state symbols and chemical equations. Let's get started. So what are state symbols? State symbols are letters that are used to show the physical state of substances in the equation. So when you have an equation that shows a reaction of one or more substances, state symbols are just letters that are going to show you what physical state that substance is. For example, calcium, we're going to use the symbol S to show that it is a solid. So when you see something like this, calcium S, it means this calcium is solid. Remember, a lot of things can happen to calcium. Maybe it can be melted. If it's melted, you have to put a symbol that shows that it's a liquid, an L here. So these are the used state symbols. So gas is represented by G in brackets, liquid by L in brackets, solid by S in brackets, aqueous solution by AQ in brackets. The question is, what is aqueous solution? So aqueous solution is any solution that is made of water and another substance. If, for example, we have got an aqueous solution of sodium chloride, it means sodium chloride has been dissolved in water. So these are the state symbols, and that's everything about state symbols. Now we'll go to chemical equations. So what is the chemical equations? Before we can even understand what the chemical equation is, maybe we understand what an equation is. So an equation is a chemical sentence which describes what is happening in a chemical reaction. Actually, this is the definition of chemical equation. Maybe we'll start from there. So a chemical equation is just an equation which is basically a chemical sentence describing what is happening in a chemical reaction. So if there's a chemical reaction, to represent what's happening, you use a chemical equation. So an example of a simple equation is something like this. So we have A plus B, then C plus D. So A is a substance and B is a substance. This plus shows that these two are reacting. They are combining chemically to give new products. The new products are shown by this. So this shows the products that are going to be given. The first product is C and D. So the plus on the other side just shows the products that are formed. These two substances that are reacting are called reactants, and these two which are being produced are called products. We take a look at what is called a word equation. So a word equation are just chemical equations written in words. So for example, we have this sentence: magnesium metal reacts with oxygen gas to form magnesium oxide. Magnesium metal reacts with oxygen gas to form magnesium oxide. So this is a statement. So we have to write this statement in words and in form of an equation, like a chemical equation, but in words. And when we do that, we have what is called a word equation. So how do we do that? So magnesium metal, we have to write magnesium. Of course, since it's a metal, it means it's a solid in this case, so I have to show the state symbol. So reacts with oxygen, reacts is going to be plus with oxygen gas. So oxygen, we have to write oxygen, and the word gas shows that it is in a gaseous state, and we have to use G to represent this. To form, we're going to use that arrow to show that something is being formed. Magnesium oxide, we're going to write magnesium oxide. In a fair case, they were supposed to state in what state magnesium oxide is, but normally magnesium oxide is in solid state, so we're going to indicate that with S. So we have this magnesium solid plus oxygen gas produces magnesium oxide solid. So this is a word equation. So from this, you should be able to tell what's happening in a. We move to another way of writing equations, which is equations with symbols. So unlike word equations where we use word to write a compound or an element that is involved in a reaction, in equations involving symbols or with symbols, we use symbols to represent a compound. So this reaction, magnesium solid plus oxygen gas, gives magnesium oxide. We have to write, instead of magnesium, we use symbols. We learned about chemical formulae and chemical symbols, nuclide notations. Of course, not nuclide notation, but the symbols that represents an element on the nuclide notation, those are the knowledge that we need to use. So for example, magnesium is being represented by Mg. You can get this on a periodic table. Magnesium is Mg. Oxygen is O2. So oxygen, whenever it's oxygen, it's O2. Oxygen as a compound exists as O2. That is, two oxygen molecules combine to form oxygen, the oxygen gas. So you have to keep that in mind. Another thing is magnesium oxide. So you have to learn how to write magnesium oxide with using chemical formulae. So what is the chemical formula for magnesium oxide? You have to remember variances. Magnesium has a variance of 2 and oxygen has a variance of 2. So if these two combine, they are going to it's going to be like Mg2O2. So the twos, since they're the same, they are going to cancel and we're going to have MgO. So somewhere on a rough paper, you can just, if you're not sure of the chemical formula for magnesium oxide, so you can just get a rough paper, then you do you try to get the chemical formula using valences. You're going to have MgO. With time, you're going to master you're going to master without even knowing the chemical formula of some common compounds such as magnesium oxide. With that being said, so this word equation can be written as an equation with symbols like this. So magnesium is this one, magnesium with a state symbol S, plus oxygen. Oxygen is O2, like I said, it's written and with a state symbol G, produces magnesium oxide with a state symbol S. So this is the word equation. I mean the chemical equation. That's what we'll be calling it normally, chemical equation for this reaction, which is being represented by the word equation here on top. So writing chemical equation, the only skills that you need is how to write the chemical formula for the compounds or elements that are involved in the reaction. The difficult part comes on balancing the equation. So what is balancing the equation? So balancing the equation is the process of making the number of each type of atom equal on both sides of the equation. So the way equations are, if a reaction has occurred, we assume that nothing has been lost and nothing new has been added. So what is here should give what is here. By that I mean, if you look at here, there is one magnesium, but here there is one, here there's one magnesium and here there's one magnesium. This is one magnesium atom and here we have one magnesium atom. So the number of magnesium atoms are balanced. But if you look at the number of oxygen atoms, here we've got 2 oxygen atoms. How do you tell? This 2 shows that there are 2 oxygen atoms. But here we only have 1 oxygen atom. So the number of oxygen atoms are not balanced because here we have 2, but in the product we have 1. So the question is, where is the other one? The other oxygen, where has it gone? So this brings in the issue of balancing the equation. Balancing the equation involves basically coming up with numbers that are going to make the number of atoms this side equal to the number of atoms this side. So if we have 10 magnesium atoms, we should have 10 magnesium atoms here. If we have 5 oxygen atoms here, we should have 5 oxygen atoms here. So that's everything about balancing the equation. With that being said, let's take a look at steps that you can recall when trying to balance an equation. So the first step is you count each type of atom in reactants and products. So count each type of atoms in reactants and products. Then those which are out of balance, you try to balance them. So how do you balance them? So here's how to balance them. Place coefficients as needed in front of symbols or formulas to increase the number of atoms or molecules of the substance that has a lower number. So let's say the way we had identified oxygen to have more atoms on the left than on the right. So you usually concentrate on that oxygen on the side with lower atoms. So you're going to add coefficient to elements or compounds that you want to increase the number of atoms. So the coefficients are numbers in front of letters or symbols or variables or chemical symbols. So in front of chemical symbols, I mean on the left of chemical symbol, you add numbers to increase the number of atoms in a given compound or element. So we are going to understand this as we take a look at an example. So sorry for this mistake. This is supposed to be point number 2 and the next is supposed to be point number 3. So repeat step 1 and 2 until the equation balances. To understand these steps, let's try to take a look at some examples. So we have got this equation. Mercury oxide with state symbol solid gives mercury, which is liquid, plus oxygen, which is a gas. So this is a word equation. We have to write the chemical equation from this word equation. So remember I said the chemical equation we're going to be referring to the equation that involves symbols. So how do you write mercury oxide? You go to valences. So mercury is one of those elements which you need to master the valence. Mercury, I don't think I had mentioned this in the previous video. Mercury, silver, gold, and zinc, if I'm not mistaken. But zinc, there are different types. There's zinc too, so they'll specify. But mercury, silver, gold, these ones you need to master the valences. So what the valence for mercury is 2, and the valence for oxygen or oxide is also actually for oxygen is 2. So the chemical formula for mercury oxide is going to be HgO. The symbol for mercury is Hg. So when we write this into chemical formulas, we're going to have HgO, mercury and oxygen. Mercury is Hg, oxygen is O, and it is a solid. Then these are going to produce mercury, which is Hg, which is a liquid, plus oxygen, which is just O2, which is a gas. So this is the chemical equation. So is it balanced? This equation that involves symbols, is it balanced? So the first step is we start counting each of the atoms in the reactants and products, and we see which one is not balanced. The one that is not balanced, we try to balance it. So we have Hg here, which is 1. You can see there's no number here or here, so it's 1. If you look at this Hg, it is also 1. So Hg is balanced. We got oxygen. Oxygen is just 1 here, but if you look at this oxygen, there are 2 oxygen here. So oxygen is not balanced. So how do you deal with this? So to deal with this, we are going to add a coefficient. A coefficient is a number, like I had said, that you put in front here. So in the I had said that a coefficient is a number put in front of symbols or letters. So these are the letters. The number that you put here is called a coefficient. So the coefficient is going to increase the number of atoms here where oxygen is less. We have 1 oxygen here, we have 2 oxygen here. So to have what we can do is we can just put 2 here, so that we have 2 oxygens here also. So when we do that, we're going to have something like this: 2 oxygens here, which are going to balance with these 2 oxygens. But in an effort to do that, we have created another problem, and the problem is we have mercury here. Mercury is 1. Now that we have put 2, so now we have got 2 mercury atoms, and here we have 1. So we have created the problem. We have solved the first problem, but in the process we created another one. So how do we solve this other issue also? Again, we have 2 here, here we have 1. So we need to balance off. How do we balance off? We add 2 here. If we add 2 here, we're going to have 2 mercury atoms. So when we do that, we're going to have 2 mercury atoms here. then we recheck the oxygen, because adding 2 can affect the oxygen if the oxygen was of course combined. But it is very it's a very good practice to recheck. So mercury 2, mercury 2, oxygen 2, oxygen 2. So this oxygen here is 2 because of this 2, and oxygen here is 2. So these numbers here, which are in front and on the bottom, are specific for this element here. But these numbers which are in front, like on the left, they correspond to all the elements. So these 2 shows that there are 2 mercury atoms and also 2 oxygen atoms. But this 2 which is on the bottom is just for 1 oxygen. If there was another element here, these 2 would be just for oxygen, not for the element here. There are special cases where we can have, let's say, HO in brackets and 2 outside. So if we have 2 elements in brackets and 2 is outside, it means this 2 is for both of the elements inside the brackets. But without brackets, this 2 belongs to this oxygen. Let's take a look. So another one is hydrogen plus oxygen gives water. So with this, we can write the chemical or the equation with symbols. It's going to be this. How? Hydrogen is a gas and exists as 2 hydrogen atoms that have combined, just like oxygen, so it's H2. And oxygen, in its gaseous state, it exists as O2. These are the things you need to know. Hydrogen, oxygen, even nitrogen, you should know how it is. Even carbon dioxide, you don't need to waste time to come up with the chemical formula for carbon dioxide. So these are the basic elements that you're going to be dealing with day to day. So you need to have them by heart. Then water, if you're not sure, but this one is also one of the common ones. But if you're not sure, you can just try to create to use valences to come up with a chemical formula for water. So hydrogen has a valence of 1, oxygen has a valence of 2. When they exchange, the 2 will come here, and the 1 which is from hydrogen will come here. So otherwise, at the end of the day, we're going to have H2O1. The 1 we don't show it, and we have H2O. With this, let's try to balance the equation. Hydrogen, there are 2. Hydrogen, there are 2. Balanced as it should be. Oxygen, there are 2. Oxygen, it's 1. Oxygen seems to be problematic. So here we have 2 oxygens, here we have 1. So we need to balance. How do we balance? We go to the side where there are less oxygens here. So we're going to add 1 oxygen. We're going to add the number here so that the number of oxygens increase. So we're going to add 2 since there are 2 this side. So if we add 2 here, then it means we have 2 oxygens. So when we do that, we're going to have 2 oxygens. But oxygen is combined with hydrogen. So putting 2 here, it's going to affect hydrogen. How? These 2 belongs to hydrogen and oxygen. So the addition of 2 here has changed the number of hydrogen that are here. So what's the number of hydrogen that are here? So what we do is, normally before these 2, there were 2 hydrogen. But this 2 here has doubled the number. Or in short, you multiply these 2 here and this, and it will give you 4 hydrogen atoms. So we have 4 hydrogen atoms, which has confused everything. But this side we only have 2. So how can we have 4? Simple, we just add 2. So that 2 times 2, again, it gives us 4. So we add 2. 2 times 2, we have 4 hydrogen atoms. And here, 2 times 2, we have 4 hydrogen atoms here. So we have made the change here. But here, there's no other element. So there's no way we can affect the equation. But it is always advisable to check. So hydrogen 2, we have 2. Oxygen, hydrogen, we have 4. 2 times 2, 4. And hydrogen this side, we have 4. 2 times 2, 4. We go to oxygen. Oxygen, we have 2. Oxygen, here, we have 2. So this equation is balanced as it should be. We have got another reaction here. Sodium plus water gives sodium hydroxide plus hydrogen. So sodium is just Na, water is H2O, sodium hydroxide is NaOH. How can you tell? So sodium is Na, hydroxide is OH, the valence for sodium is 1, and the valence for hydroxide is OH. So when you do cross multiply, you exchange the valences, you're going to have NaOH like so. So sodium, I said it's Na, water is H2O. So we're going to have sodium and OH when the valences exchange. Hydrogen exists as 2 atoms combined, which gives this H2 gas. With that being said, we have to balance. Sodium we have 1. Sodium we have 1. Good. We go to hydrogen. Hydrogen we have 2. hydrogen here, we have 1, but there's also hydrogen here. So this is a new case. We have hydrogen in 2 different compounds. So we have hydrogen here in this ionic compound, and we have got 2 hydrogens here in this covalent compound. Of course, the way I tell that this is ionic and this is covalent, it's through experience. Anyway, you also gather that. So as I was saying, hydrogen here we have 2, here we have 1, and here we have 2. So the total of hydrogen is 3, which is strange because there are 2 here. How can we have 3? So we need to balance this. How do we balance this? So it's hard because here we have 2, here we have 3. So there's no way, there's no number which we can add here and it's going to give us 3. Number which if multiplied by 2 is going to give us 3, unless it's a number that has got points. But let's try to use whole number. So whole numbers, which means numbers without points. So how do we tackle this one? So we can put 2 here. When you put 2 here, it's going to be 4 here. Okay? So it's 4 here. Here we have 2, and here we have 1. So this one, which is alone here, we can put 2 here. If we put 2 here, then we are going to have 2 hydrogen and 2 hydrogen, 4, just like here, 4. So what I'm trying to say is this. So I'm going to put 2 here first. So we have 2 hydrogen plus 2 hydrogen, 4. And I'm going to put 2 here. We have 4 hydrogens. So hydrogens are balanced. But this has created or has caused havoc on the equation. How? If we go back, this 2 is going to affect the number of oxygen, which you haven't even analyzed. This 2 is going to affect the number of sodium, which you haven't analyzed. So let's try again. Let's start again. Sodium we have 1. Sodium here we have 2. So remember, this 2 is for everyone. So sodium we have 2. So we have got a big issue here. So how do we deal with this catastrophe? So we have 2 sodium atoms here. So maybe we add 2 here so that the number of sodium atoms are equal. So we are going to add 2. When you add 2, we are going to have 2 sodium atoms, 2 sodium atoms, balanced as it should be. And the fact that sodium is alone, it means it's not affecting anything. But anyway, we'll recheck at the end. So we have 2 sodium atoms, 2 sodium atoms. We have just added the number here. What about hydrogen? Hydrogen, 2 times 2, 4. We have 4 here. We don't have any hydrogen atom here, so we have 4. And this side, we have this hydrogen is 2, plus this is 4. We got oxygen, which we haven't yet analyzed. How many oxygen atoms are here? So this 2 belongs to this hydrogen. This oxygen has no any number here. So oxygen, there are 2 oxygen atoms. Oh, that's good. What if we go here? How many oxygen atoms are here? So I've got oxygen only here, and if we look here, there are 2. So oxygen is also balanced as it should be. So we are lucky, and this is how to balance this complicated equation. Finally, let's take a look at calcium oxide plus hydrochloric acid, which produces calcium chloride plus water. So calcium oxide is CaO, hydrochloric acid is HCl. So hydrochloric acid, yeah, this is a strange one. Hydrochloric acid, yes, how do you come up with the chemical formula? Anyway, this one is one of those which you need to know, of course. But of course, it's just an acid that is made of hydrogen and chlorine. So this is the valence for hydrogen, it's 1, and the valence for chlorine, it's 1. So we're going to have this. Calcium chloride, calcium valence is 2, chlorine it's 1, so it's this. Water is H2O. So now that we have calcium oxide plus hydrogen chloride or hydrochloric acid, calcium chloride and water, is this balanced? So we start with calcium. Calcium is 1 here, calcium is 1 here. Very good. We go to oxygen. Oxygen is just 1 here, there's no oxygen here, so it's 1. If we go here, oxygen, there's no oxygen here, it is only 1. Awesome. So we go to hydrogen. Hydrogen here, it's 1, which is good. And when we go this side, hydrogen is 2. We are in trouble. Hydrogen is 2 here, and here it's 1. So to balance, we just have to add 2 here, so that we have 2 hydrogens here and 2 hydrogens here. So we have done that. But adding 2 hydrogens here is affecting the number of chloride atoms. So I mean of chlorine atoms. There's no such thing as chloride atoms. So unless I say chloride ions. So there are two chloride ions here, or two chlorine atoms. So how many chlorine atoms do we have here? If you look at this, we have Cl2. We have two chlorine atoms balanced. So let's recheck. Calcium 1, calcium 1, oxygen 1, oxygen 1, hydrogen 2, hydrogen 2, chlorine 2, chlorine 2. So we have two chlorines here and two chlorines here. So everything is balanced as it should be. So this marks the end of chemical equations. So in the next video, it's going to be very short. It's going to be very short because it's just going to deal with ionic equations. So I hope you get the skills that are necessary. And after this, make sure that you find questions to work with so that you just get the skills needed. Happy solving.